So this lecture contains the introduction to the basics of DC circuit, where you are going to study what is sources, what is ideal and practical source, what are the independent sources and dependent sources. So the learning objectives of these lectures are to make the students understand basic concepts of electrical sources and the concept of ideal and practical sources and concepts of independent and dependent sources with respect to these electrical networks. After successful completion of this lecture, students will be able to understand the basic concepts of electrical sources, and students are able to identify the ideal and practical sources. Students will be able to identify the independent and dependent. So now we will move upon what is source basically. This source is a basic network element which supplies energy to the network. Say this is one of the example of electrical network where voltage source is supplying energy to the circuit, where the circuit network element is here resistance, and because of this voltage source the current is flowing into the network. So this is one of the example of source. This another circuit shows the example of current source where 3 ampere current source is supplying to the energy to the network elements of 500 ohm resistor and 250 ohms resistor. So there are different types of sources. For example, voltage source and current source. This voltage source is again divided into ideal voltage source and another part is the practical voltage source. Similarly, current source is divided into two types, ideal current source and practical current source. So what is the meaning of ideal and practical that we are going to discuss here? So here you are seeing the first figure where current I is flowing between point A and B, and that point A and B is given to the network where the network is supplying energy through this current source I. But since there is no opposition for this current, so whatever current is supplying, that is completely transferred to the network, and hence this current source is called as a ideal current source. The characteristics of this current source with respect to voltage is given here, where the magnitude of current is constant. Why it is so? Because internal resistance is zero in this case. Whereas when we are talking about the practical current source, internal resistance comes into picture. This internal resistance of current source is always connected in parallel between point A and B. Again, that point A and B is given to the network where you have to supply the energy. But since now there is a opposition for the flow of current, so the magnitude of current will not be constant in this case. That is why the characteristics of practical current source is moving down. When we are talking about the voltage source, in case of ideal voltage source, whatever voltage you are applying between the terminal A and B, that is given to the your electrical network. And since again in this case the resistance is zero, internal resistance, I am specifying that the internal resistance of this voltage source is zero in this case. That's why whatever voltage is supplying to the network, equal amount of voltage is transferred, and hence the characteristics is constant voltage is applying. Whereas in case of practical voltage source, internal resistance comes into the picture. Here it is shown by small letter r. Since internal resistance is there, so there will be opposition for the flow of current. So equal amount of voltage is not transferred to the network. whichever is connected between point A and B, and hence the characteristics looks like this. This is all about the ideal and practical current source and voltage source. Now just we will brush up whatever we have studied till now. So I wanted to ask one question, that internal resistance of ideal voltage source is, yeah, it is 0. Second, the internal resistance of ideal current source, correct, it is infinite. Next question, the internal resistance of practical voltage source, yes, very true, it is not 0 since it is a practical source, so resistance will be there. Last question, internal resistance of practical current source is, yes, again it's not infinite, it has some values. Now another topic, that is independent sources. So what is this independent source? Whose output characteristics of a source are not depend on any network variable such as voltage or current. This is one of the example, or you can say the pictorial representation of independent current source. It may be independent voltage source also. Independent voltage source is represented by battery also. Now move on to dependent source. What is this dependent source? If the voltage or current of a source depends on some other voltage or current, then it is called as a dependent source. Here some of the examples are shown for dependent source. This we are going to study one by one in the next point. Voltage controlled voltage source VCVS, current controlled voltage source CCVS, voltage controlled current source VCCS, and current controlled current source CCCS. So firstly we will discuss about the voltage controlled voltage source. What is this? A voltage across the input terminals controls a dependent voltage source at the output port. This is nothing but the voltage controlled voltage source. The representation of dependent source is shown in point A. Then current controlled voltage source, where a current flowing through input terminals controls a dependent voltage source. Voltage controlled current source now account for a dependent current source at the output terminals with a voltage across the input. You can control the amount of current output, that is nothing but your voltage controlled voltage source. And the representation is shown in point B. Then current controlled current source. With a current flowing through the input port, one can control a dependent current across at the output port. That is a current controlled current source. I hope all of you understand these concepts. So we will again have a small quiz. So if a voltage across the input terminal controls a dependent voltage source at the output port, then it is right voltage controlled voltage source. Second question, a current flowing through the input terminal controls a dependent voltage source, that is, yeah, current controlled voltage source. A voltage across the input terminal controls a dependent current source at the output port is, yeah, voltage controlled current source. A current flowing through the input terminals control a dependent current source is, correct, current controlled current source. So for this topic, book recommendants are D. Rai Chaudhary, Networks and Systems, Van Valkenburg, Network Analysis, Franklin and Co., William Hart, and so many books are there. These are the online resources. Thank you.